In this presentation, we'll explore using CAD data in ArcGIS. This is an adapted PowerPoint from an Esri technical workshop put on by Phil Sanchez and Jeff Reinhardt. I've updated this PowerPoint to include some of my own slides and information, but appreciate the work that was done by Esri to get started with this PowerPoint. So we'll look at an overview of ArcGIS CAD support. We'll also explore CAD data in general. We'll look at using CAD data sets in ArcMap. We'll look at georeferencing CAD data, loading CAD data sets and features into a geodatabase, some of the geoprocessing tools available for CAD data, some best practices for GIS and CAD interoperability, and also using ArcGIS for the AutoCAD product. So the first thing I'd like to discuss is some of the difference between CAD and GIS. Before we do that, it might be worth mentioning what CAD is. CAD stands for Computer Aided Design. CAD is a design product that was made primarily to automate the old manual drafting design techniques. So it's drafting and design on the computer. CAD is used to design almost everything from probably your favorite toothbrush to maybe parts of a car. CAD is used to design furniture and houses. We also use CAD to design a lot of real-world geography-based things. Surveyors and engineers use CAD to design water systems and surveys of property, as well as roads and bridges and all kinds of other real-world things. So CAD data is primarily a design and drawing tool. This is different from how GIS is used primarily. GIS, where we do design and create data through editing, GIS is primarily used for data analysis and a mapping tool. Whereas CAD was developed to automate drafting functions, GIS was developed for high-level spatial analysis and management. In CAD, features are represented by a graphic symbol. It's more graphic driven. The features are defined by symbol colors, line widths and types, and we can symbolize features in a GIS. However, features in a GIS are stored as simple cartographic features, and they're linked to tables of attribute information. So in a GIS, the attributes are combined with the spatial data to make a more powerful spatial database. CAD is oftentimes, the data is stored in a local coordinate system or not stored with some kind of real-world coordinate system like latitude and longitude or state plane or UTM coordinates. In a GIS, our data layers are almost without exception always stored with some kind of real-world coordinates, whether they be a geographic coordinate system like latitude and longitude, or a projected coordinate system of state plane or UTM. CAD data is often built without explicitly defining connectivity between some of the features that are created. It's not that CAD doesn't have this functionality. There are powerful snapping tools within the CAD environment that can ensure connectivity is built when the design is implemented. However, sometimes these connectivity tools and snapping aren't applied in the ways they should, so you'll see gaps in data where it shouldn't be. In a GIS, connectivity is defined through powerful topological data models and through snapping techniques. And connectivity is a very important concept in GIS. GIS works on a topological model that that defines spatial relationships between features, how features connect, and what features are adjacent, contained within, connected to other features. And CAD doesn't necessarily work on such a strong topological models. In a CAD also, layers are not sometimes well organized. CAD does work on a system of layers. However, oftentimes CAD technicians don't take time to separate information into appropriate layers in a way that makes them easy to use in a GIS. It's not necessarily at fault of the CAD technician. Even in the CAD environment, organizing things into specific layers would probably make things easier to use and be more well organized. To their defense, they're not building their CAD data necessarily to be used in GIS, which is something we'll get to later. If CAD technicians did work harder to build their data in a way that it would be able to be used in a GIS, if they focused on that, the data would be easier to use in GIS. In a GIS, layers are built thematically. We don't mix different kinds of things into the same layers, even when we're being sloppy and not taking the time to well organize things. A GIS has thematic layers. We'll have a layer of trees and then a layer of manholes, and they both are points, but you won't ever see these in the same layer. Sometimes those kind of things get mixed into one layer in an AutoCAD file, and we have to extract those out using some kind of filtering techniques. Another big difference between CAD data and GIS is that CAD data are not stored with feature attributes. So attributes are a major part of all geographic information systems. But in the CAD world, user-defined attributes of things like a tree type and a tree height, those kind of things aren't necessarily stored. You will see attributes in CAD data, but the attributes store more display characteristics like the color of the line and the type of the line and the width of the line. They store display characteristics rather than real world kind of information about a feature. All of this being said, over the years, CAD has definitely become more GIS-like. There are extensions for CAD programs that allow you to build and store attributes and do spatial analysis. And GIS systems have become more CAD-like. Like the data editing and creation tools in ArcGIS have gotten much better and are much more like the CAD development and drafting tools. So these two things are kind of coming together a little bit in their functionalities. So I mentioned most of this. Computer-aided design, CAD drawings are digital representations of a design or some kind of existing object. These types of files are vector-based, and they're used in professional disciplines like engineering, architecture, surveying, and mapping. They are a popular format for storing and exchanging vector-based spatial information. In ArcGIS, you can connect directly to CAD files and display them as read-only without using any kind of conversion tools. So we can overlay CAD data directly in ArcMap with our GIS data. So these are some CAD GIS interoperability scenarios. An ArcGIS user who needs to do any of the following may have a set of scenarios and procedures they use to work with GIS data. Sometimes you may just display CAD data in a map in conjunction with your other GIS data. If you want to edit and manage the information that's in the original native CAD file, if you want to edit and update that data, you have to load the CAD data into a geodatabase. You could also convert it to a shapefile, but a geodatabase is a more relevant and current format. And sometimes you may want to take your GIS data and convert it to CAD format. I had a bunch of contour lines that I had in a GIS format, and a student wanted to feed it into a milling machine, a CNC machine, to cut out a 3D model out of a wood block. And so I converted my GIS data of contours into a CAD file so that he could use the CAD file in his CNC machine. So, as far as how we use CAD data in a geospatial context, we use CAD data that was developed in industries like surveying and civil engineering and planning, among others, as a large source of GIS data. A lot of the GIS data you commonly see may have started as a CAD file. For instance, there's a planning community in Asheville called the Givens Estate, and they manage their campus planning using a bunch of CAD data, and a planner, an architect, and an engineer and surveyor that manages the growth of their campus. They do it in AutoCAD. That data was then converted into a GIS format to manage as a GIS. The same is true for AB Tech's campus. The engineers and architects that help us to manage our 5 and 10-year master plans have our master plan of the campus implemented as a CAD file. And we'll take that CAD file and use it as a basis for building some of our GIS data. During this process, you'll see how the data is a great start for building your GIS database, but often takes other editing and processing to make work in the way we need. So this is an example of what some CAD drawings look like in AutoCAD. I don't have AutoCAD loaded on this computer, so this is a good example of what CAD files look like. They're comprised of geometries, text, and symbols. These are the entities or elements of CAD data. They are organized into layers, sometimes called levels, sometimes organized into better layers than others. There is symbology that represents the information, and they can have data attached to these entities. Most of the time, the data you'll see are, again, display characteristics like the line of the color, the type of the line, and the width of the line. But attributes can also be attached, like the kind of attributes we're used to seeing in the GIS environment. They're user-defined attributes, like the owner of a parcel, the acreage of a parcel, things like that. And this shows what the CAD layers look like in AutoCAD. You can see the layers over here, and these define the display attributes, the color, the line type, the line width. There's a description of the layer, and you'll see these layers look like they're organized pretty well, so different types of roads are on different layers. You'll also see the color of the layer and some other information about how this CAD drawing is organized and displayed in AutoCAD. When we look at these CAD data sets in ArcGIS, again, they're automatically read. There's a direct read engine. It's read-only, but you can see different geometries, the CAD entity organized into feature classes, whatever attributes there are, as well as coordinate system and world file information. So we use the coordinate system information to project our layers on the fly, and the world files are used to transform the local coordinates to projected coordinates, and we'll see all of that in this module for this class. So here's your drawing file over here with properties and user attributes, geometries, and the way it looks in ArcGIS is you've got these individual feature classes along with attribute tables. It's translated on the fly as these virtual feature classes. So it looks very different than how it looked in the AutoCAD world. This CAD data support has been long supported in ArcGIS. They've had a lot of different integration tools and ways of working with CAD. It's out-of-the-box functionality with no additional extension required. You don't have to convert the data to view it. You do need to convert it to a GIS data format like GeoDatabase if you want to edit it. The current version is at AutoCAD, DWG, and DXF up to 2015, probably 2016 now, I imagine. So DWG and DXF are the two most common formats you'll see, but it also supports DGN for MicroStation as well, something we don't see as much unless we are working with a Department of Transportation. Many DOTs use MicroStation, whereas most architects, engineers, and surveyors use AutoCAD. So this is another slide that shows these feature classes as they're displayed in ArcGIS. We have annotation with text, tags, and attribute definitions. Multi-patch is a type of feature class with polygons as well as other 3D representation types of things. We don't see as much multi-patch. You can have points with blocks and cells. You can have polygons that are closed areas. You can have polylines, which are like lines, polylines, and arcs, as well as projection files that define the coordinate system of the CAD data set. We see most often the polyline feature class is the one we use. We do see a good many points as well, but we'll talk more about that as we move on. So in addition to these, what I refer to as generic kind of feature classes, multi-patch, point, polygon, and polyline, you'll occasionally see feature classes that were defined using an Esri standard for CAD technicians to build data in a way that it can be read in ArcGIS. So these generic ones, again, polyline, polygon, point, multi-patch annotation, you see a lot of. And a lot of times the different layers within the CAD data set are all clumped into the same type of geometry, like a polyline. So you'll see all of the polylines, whether they're roads or streams or sewer lines, dumped into this one polyline feature class, and you have to select them out based on an attribute, and we'll see that. Occasionally you'll see feature classes that are thematic in nature, like a parcels or a roads. Again, these are built using an Esri standard, an MSC, that we'll see later in a slide. One more view of a CAD data set. This is in Arc Catalog, where you've got the CAD data set and these feature classes within the CAD data set. Projection files, again, store projection information, and world files are how we translate from local coordinates to projected coordinates. We'll see that later in the presentation as well. So when we load CAD data into ArcGIS, we can control what is shown through layer properties. If you go to the properties of the drawing, of the CAD drawing, this is the layer properties dialog, there's a tab called drawing layers. That tab is not there unless you're looking at the properties of an actual CAD file. From within there, you can turn layers on and off. This helps to pare down or filter out some of the information that's displayed. There's other way to filter CAD features as well. Using definition queries, you can create subsets. So again, under the layer properties, you can go to a attribute and pull out certain thematic layers based on an expression here. This is pulling features out of the layer where they have a building and there's a certain color and line type. So that just controls display. If you perform this kind of operation using a select by attributes, you could select this set of features and then convert to your own GIS data format. And we do that to thematically filter out information out of the CAD file and create thematic layers in our GIS to pull out just the buildings out of the whole CAD file and put it in a buildings layer. Something else we'll also see. So when we filter CAD features, we're essentially isolating the CAD data that we need to work with. So we pull out specific CAD feature classes. Again, we can do it by drawing layer visibility, definition query, or select by attributes. And oftentimes, once we get this part of the layer isolated, so it's just showing parcels, we'll export those to a feature class in our geodatabase, and we'll call it parcels. So we can generate these GIS layers that are thematic in nature, which is what we're used to doing in GIS. It's how we like to build and organize our data into thematic layers. So we can pull information out of a big CAD data set that has a lot of different information. We can filter it down to a individual thematic set of information and convert it to a GIS layer. So a little bit about displaying CAD data in ArcGIS. How do we display it in ArcGIS? Well, oftentimes we have to geo-reference CAD data to get it to fit with our other GIS information. So what is geo-referencing? Geo-referencing is the process of assigning a coordinate system and applying a transformation to a CAD data set or to a image that has not been geo-referenced. If you took GIS 111 here, we applied a geo-referencing process to a scanned paper JPEG. We use a geo-referencing toolbar that's part of ArcMap, and it allows us to geo-reference data that doesn't have coordinates, and we can geo-reference it to match something that has coordinates. So again, the geo-referencing tools in ArcGIS are used for CAD data and scanned maps or images. Not all CAD data sets require this. Some CAD data sets are already built using real-world coordinates. We mentioned one of the disadvantages of CAD data, potentially, is that they were not built using real-world coordinates. Oftentimes you get data that are in a local coordinate system, and then you use this process to geo-reference the CAD data. Similar to georeferencing, we also need to often assign coordinate systems to CAD data. This is referred to as defining a spatial reference, and by defining a coordinate system or a spatial reference, it allows CAD data to project on the fly to align with other map layers. This is the same process we go to when we define a coordinate system or spatial reference on GIS data. In order for any kind of layer to project on the fly in ArcMap, whether it be CAD data, GIS data, a geodatabase feature class, an aerial photo, anything, the coordinate system has to be defined. So there's no difference for defining CAD data's spatial reference coordinate system than other data. When you're working in ArcGIS, spatial references, coordinate systems need to be defined, and CAD data, it also needs to be defined. So it works at the CAD data set level, the highest level. You look at the spatial reference properties, and you can apply a spatial reference to a CAD data set. Esri uses a universal projection file or a .prj file that applies the same coordinate system to all CAD files in a workspace. So with projection files, it's a PRJ file. When you geo-reference data using the georeferencing toolbar, you create a world file. These .wld files apply the georeferencing transformation to CAD files, and it works for all the subset of feature classes within a CAD feature data set. So here's an example of some CAD data that's not in a real world coordinates, and we have some parcel data here that is in real world coordinates. So what you do is you reposition the CAD data set to align with the real world GIS data with real world coordinates. When you reposition or georeference CAD data, you can move it over to another location, you can rotate it, and you can scale it. Again, this isn't required for all CAD drawings, but for the ones that are not in real world coordinates, it is required. So we said we can move it, scale it, and rotate it. This is referred to as a two-point similarity transformation method. Moving, rotating, and scaling makes sure that the aspect ratio is always maintained, and it does not allow you to skew or rubber sheet a CAD drawing. This keeps the CAD drawing very accurate in comparison to the original CAD drawing. That's the one difference in georeferencing CAD data versus what we saw in GIS 111 when we georeferenced an image. With an image, you can add more than 2 points, and you can rubber sheet a scanned image or map to make it fit better. Since CAD data is read-only and not editable, it doesn't allow for that. This transformation is managed by the world files. ArcGIS is not modifying the CAD drawing. The world file uses the CAD file name as the prefix, then .wld, and ArcGIS automatically reads that file and moves the CAD data based on the information in the world file. That world file must reside in the same file as in the same folder as the CAD data, and it's really a simple text file that stores the from, x, and y in local coordinates, and then the to x and y in real world coordinates. So for a position on the CAD file, you have to find some real world coordinates with real world data. The simple text file has two sets of coordinates. Like we said, it's a 2-point similarity transformation. And the georeferencing toolbar builds this file when you click the Update Georeferencing option. You could very easily build this file by hand, and we did for many years before there was a georeferencing toolbar. So here's the georeferencing toolbar. It provides a way to use it's kind of a point and click method for clicking on the from XY coordinate and the to XY coordinate. You can rotate, scale, and shift and fit the CAD data to display. You'll see a demonstration of this during our demo of our exercise. So the georeferencing process is to define a coordinate system, add to the map, fit to display, add some control points, and then update the georeferencing, which builds the world file. Again, remember, we're not actually modifying the native underlying CAD data. The world file is used to simply display it in a different location. So, how about taking CAD data and loading it into ArcGIS? We can add to geodatabase feature classes or create new geodatabases from the CAD. As CAD files like as-builts update, we can update our geodatabases. There are certain editing requirements, and there are some geoprocessing tools and tasks that we can use to model CAD data in ArcGIS. Conversion is also supported by this geoprocessing framework and ArcMap tools, and can be combined with other things like spatial joins, which allow us to combine attribute information with some of our CAD data, as well as manipulating or editing the geometry. So the conversion tools, a lot of things we do right in ArcMap, like selecting a set of geometries in a CAD file and then converting them to a geodatabase feature class. There are also a bunch of geoprocessing tools that do similar functions, but in reality I find most of these are just as easy to do during an edit session or outside of an edit session in ArcMap. One exception is the import CAD annotation. If you want to get annotation out of a CAD file, the import CAD annotation tool in ArcToolbox is really powerful, as well as the CAD to geodatabase tool. The CAD to geodatabase tool is useful if you have many different CAD files that are built with the same schema for different areas, and you want to combine them all into individual feature classes. It's essentially designed for bulk loading CAD data sets. So it combines copy features, merge, and import into a single tool that works at the data set level. It pulls in everything out of your geodatabase, however. So if you just need a few things out of your geodatabase, just doing selections in ArcMap, using select by attributes, and converting to individual feature classes can sometimes be just as proficient, and that's how we'll see most of the work done in our work this week. So some more interoperability scenarios between CAD and GIS. Again, you either want to view GIS data in CAD, which there's direct read, you can do that. If you want to edit the GIS data in CAD, you need a plugin, or if you want to provide drawings to GIS users, you can export to CAD data. So some best practices. When you're exporting, if you want to retain some of the attributes in the GIS in the resulting CAD file, you need to use a seed file or a template file that helps you to create what are called blocks in AutoCAD, and they attach attributes to features. You want to use a set of layer standards so that you make sure everything's on a good organized layer and things aren't mixed up. Make sure you use coordinate systems and you're drawing in real world coordinates. So these are all good best practices. When you export to CAD, you can output to DGN, DWG, or DXF. It supports appending to existing CAD drawings. This is available at all license levels of ArcGIS, and you can create seed files as well as CAD feature classes with the MSC or the mapping specification for CAD. So we saw this when we saw individual layers that were broken out of the CAD file for things similar to what we'd see in a GIS where they're thematic in nature, like roads or parcels. It's an open source framework that was developed by Esri just for coding information into DWGs to define things that help us in the GIS, like GIS feature classes plus the attributes, as well as coordinate systems. It utilizes CAD data structures to define schema and store data, and that makes it come through to the GIS in a more GIS friendly way. It's leveraged by ArcGIS CAD tools as far as the direct read and import tools, as well as export to CAD. It provides improved interoperability between CAD and GIS, and if GIS technicians use the mapping specification for CAD, the data is easier to use once it gets to the GIS. There is an ArcGIS for AutoCAD plugin, so if you work in AutoCAD and you want a plugin that streamlines information sharing between GIS and CAD, you can use the AutoCAD plugin. It provides access ArcGIS for server, map services, as well as image services within AutoCAD, so you can load ArcGIS map services in AutoCAD. Provides location services as well as the ability to edit enterprise geodatabases using ArcGIS for server feature services. It supports things like domains and subtypes, which we'll learn about later in our geodatabase discussions, as well as the new Lisp API, which is Lisp is the programming scripting tool for AutoCAD. So why would my CAD users care? This AutoCAD plugin provides access to GIS content, things like base maps, images service, and location services within AutoCAD. You can also access other mapping type web feature services for direct editing of GIS data, subtypes, and domains, and it's free. So, in review, there are various ways to work with CAD data in ArcGIS. You can directly read the data. You can reposition your CAD file. You can load it into a geodatabase so that you can edit it and build bigger databases from existing CAD data. And you can export files to CAD formats. There are best practices for digital submissions, and there's also a plugin for AutoCAD that helps you to work with GIS data in AutoCAD. Okay, look forward to doing the next video on a little demo of working with CAD data in ArcGIS.